It was the summer of 1943. Somewhere on the Eastern Front, the air smelled of oil, smoke, and burning rubber. A small group of German mechanics stood around the wreck of an American-made tank. Its armor was scorched, its turret half buried in the mud. The front line had moved on, but what they had found would shake their faith in Germany's war machine. They weren't soldiers. Not really. These were the men who kept the Wehrmacht's engines running, the grease-stained hands behind the panzers, the forgotten backbone of Hitler's armored spearheads. Their world was a blur of broken gearboxes, cracked cylinders, and scavenged parts. Every bolt mattered. Every drop of oil was rationed. Every repair could mean the difference between life and death. But this wreck was different. It wasn't German. It wasn't Soviet. It was American. The mechanics circled the hulk carefully, their boots squelching in the mud. One of them brushed away soot from a plate on the engine block. The letters were still visible through the grime. General Motors. That moment changed something. Because of the German mechanics who had spent years repairing clunky Maybach engines and scavenging spare parts on the battlefield, this engine looked alien. It was simple, powerful, and most importantly, it was built for mass production. They didn't know it yet, but what they were looking at wasn't just an engine. It was a symbol, a machine that represented everything Germany could never match. And in that quiet field, far from Berlin, a group of weary mechanics began to realize that no matter how bravely their soldiers fought, Germany could never win a war against an enemy that could build 1,000 of these for every one panzer. But to understand how this moment came to be, we need to step back. At the start of World War II, Germany was at the height of its military confidence. Blitzkrieg, lightning war, had stunned Europe. Panzer divisions sliced through France in weeks. The Wehrmacht looked unstoppable. But behind the scenes, deep inside the Reich's industrial system, there was a growing weakness that no one wanted to talk about. Germany's engineering culture was obsessed with perfection. Every machine was a masterpiece of precision. The engines were designed like watches, tight tolerances, hand-fitted components, intricate craftsmanship. The Maybach HL-230 engine that powered the mighty Tiger tank was a technological marvel. 23 liters, 700 horsepower, meticulously built. But it took time. Too much time. Every Tiger required weeks of skilled labor, specialized parts, and precision machining. And in a war that demanded quantity over perfection, that obsession was fatal. Meanwhile, across the ocean, the United States approached production like an entirely different science. To them, the key wasn't perfection, it was repeatability. Henry Ford had already revolutionized mass production decades earlier. The American factories that once built cars now built tanks, bombers, and trucks, using the same principles of assembly line efficiency. The Sherman tank, the M4, was not the best tank on the battlefield. Not even close. It was outgunned by the Panther, out-armored by the Tiger, and slower than both on rough terrain. But the Sherman had one advantage that made all the difference. It could be built faster, cheaper, and in numbers that defied imagination. By 1943, the U.S. was producing more than 1,000 Shermans a month. Germany, by comparison, could barely manage a few hundred tanks of any kind. And those tanks were increasingly plagued by shortages. Steel, fuel, rubber, and even ball bearings became luxuries. German mechanics knew this better than anyone. They lived it every day. Tanks were constantly breaking down. Engines overheated. Transmissions failed, and parts were scavenged from wrecks. Some frontline mechanics became scavengers themselves, stripping destroyed tanks to keep a handful of others running. When the captured Sherman engine arrived at their field depot, the mechanics didn't expect much. They assumed it would be crude, a monkey machine, as they often mocked Allied vehicles. But as they pulled apart its components, something unsettling happened. They realized the Americans had achieved something Germany never could: reliability through simplicity. The engine, likely a Continental R975 or a Ford GAA, was designed not to impress engineers, but to work. Its layout was straightforward, its components standardized. Bolts and fittings could be replaced interchangeably across hundreds of tanks. Parts were marked with clear serial numbers. The filters, fuel lines, and carburetors could be accessed in minutes. for German mechanics accustomed to wrestling with cramped engine bays and complex fittings. This was a revelation. They could tell right away. This machine was built not by craftsmen, but by industry. That realization began to spread quietly through the Wehrmacht's logistical backbone. Reports circulated. Allied tanks were not better individually, but they were everywhere. When a Sherman was destroyed, another replaced it within days. When a German tank broke down, it might be abandoned for lack of parts. And as the war dragged on, that pattern repeated itself endlessly. The Wehrmacht could win battles, but it couldn't win replacements. Factories in the U.S. Midwest were running 24 hours a day, churning out engines, gearboxes, and chassis by the thousands. Ships carried them across the Atlantic faster than Germany could even repair what it lost. By 1944, the imbalance had become catastrophic. While Germany struggled to fuel a handful of divisions, the Allies rolled into Europe with an industrial army that never ran out of machines. But the captured Sherman engine wasn't just mechanical curiosity. It was a symbol of what Germany had fundamentally misunderstood about modern war. War was no longer about who had the best machine. It was about who could build the most. The Wehrmacht mechanics who studied that engine didn't have the words to describe what they felt. But deep down, they understood Germany's war was lost not on the battlefield, but in the factories. And as they disassembled that engine piece by piece, they were also dismantling an illusion, the illusion of German superiority in engineering and production. They could fix a tank, but they couldn't fix an empire built on pride instead of pragmatism. In the years that followed, historians would look back at moments like these, small, quiet encounters on forgotten battlefields, and realize they told a greater truth about World War II. The war wasn't won by the best tank or the bravest soldier. It was won by the nation that turned steel into strategy. And for those German mechanics in the mud of 1943, the lesson was painfully clear. The Sherman engine wasn't just a captured trophy. It was a mirror showing them the future they could never build. When the German mechanics hauled the captured Sherman engine back to their workshop, it was more out of curiosity than official duty. They'd seen wrecks of Soviet T-34s before. Tanks whose engines were crude but brutally effective. But this one was different. This was something new, something unfamiliar. They laid it on a makeshift workbench, its metallic shell gleaming dully under a low-light bulb. Around it stood men who had spent years with grease-stained hands, men who could rebuild a Maybach HL-210 blindfolded. They knew every bolt, every valve, every piston of German engineering. And yet, as they stared at the American machine before them, they realized they didn't quite understand it. At first glance, the engine didn't seem impressive. It wasn't huge or intimidating. In fact, it looked simpler than anything the Germans would have expected from the enemy. When a mechanic scoffed, "Primitive," he muttered in disbelief. But when they started to disassemble it, piece by piece, that scorn slowly turned into silence. Each component fit perfectly into place, clean and uniform. No hand fitting, no micro adjustments, no delicate alignments. Everything about it was designed to be identical, from one engine to the next, from one factory to another. They measured tolerances. They checked the fittings. And the realization began to sink in. This was an engine built for replication. It didn't need a master craftsman. It needed a production line. The Americans had somehow managed to take the concept of reliability, something German engineers prized, and mass-produce it by the tens of thousands. Some of these captured engines were Continental R975 radial engines, adapted from aircraft designs. Others were Ford GAV8S, massive, all-aluminum beasts that delivered over 500 horsepower. Both types had one thing in common. They were rugged, overbuilt, and easy to maintain. Unlike German engines that demanded precise calibration and regular overhauls, these American power plants could run in brutal conditions with minimal care. They could tolerate dirty fuel, rough maintenance, and long hours of continuous operation. For mechanics who were used to coaxing finicky Maybach engines back to life, it was like discovering another philosophy of engineering entirely. In Germany, engines were designed like art, every part handcrafted, every piece fitted by skilled labor. In America, engines were designed like tools, simple, tough, and replaceable. And that The mechanics realized was the key difference. One of them reportedly said, "We build machines to last forever. They build machines to win the war." As they compared notes, they began noticing subtle things that spoke volumes about America's industrial mindset. The bolts were standardized, same threads, same sizes, making them interchangeable across vehicles. Filters, spark plugs, even bearings followed a strict system of compatibility. That meant a mechanic in Africa, Italy, or Normandy could repair Sherman with parts from another theater. In contrast, a German mechanic on the Eastern Front often had to cannibalize two broken tanks to make one work. Even the tools were a revelation. American tanks came with onboard toolkits, carefully arranged, clearly labeled. Every soldier knew where each wrench and lever went. The Germans had no such standardization. Their kits varied by unit, by model, by year. This was industrial war, and the Americans had mastered it. As the mechanics continued their inspection, they began to talk among themselves, half in admiration, half in disbelief. One joked bitterly, "If we had factories like this, the war would already be over." Another, older one, replied quietly, "It is already over. We just haven't been told yet." It wasn't only the mechanics who felt this realization. Across occupied Europe, captured Allied equipment, trucks, jeeps, tanks, kept shocking the Germans in similar ways. Every vehicle they found told the same story. The Allies had made their machines for war, while Germany had made theirs for prestige. To understand what that meant, consider this. By 1943, America's Detroit Arsenal tank plant, just one of several factories, was producing a Sherman tank every 25 minutes. 25 minutes. While a single Tiger tank took weeks to assemble and required an army of machinists and inspectors, Shermans rolled off American assembly lines like automobiles. The difference wasn't just quantity, it was a philosophy behind it. The Tiger's engine was an engineering marvel. 12 cylinders, 700 horsepower, meticulously built. But it required high-octane fuel, constant maintenance, and frequent repairs. It was powerful but fragile. The Sherman's engine, by contrast, was less powerful but infinitely more reliable. It could take abuse, run on lower quality fuel, and be repaired in the field with minimal tools. And when one broke down, it didn't matter. There were 10 more on the way. That was the nightmare for men of the Wehrmacht. No matter how many Shermans they destroyed, more kept coming. The mechanics' discovery of the captured engine spread quietly up the chain. Reports reached local command posts, and eventually, high-level officers began receiving technical analyses of Allied engines and production techniques. German engineers were astonished to learn the Americans were using automotive production lines to build tank engines, a concept that the Reich's bureaucratic system could never fully embrace. Even attempts to copy or adapt those methods fell short. The German industrial structure was fractured, different companies, rival ministries, overlapping designs. There was no single streamlined production model like Ford or General Motors. Every new tank design required retooling factories, retraining workers, and redesigning parts. The Americans, meanwhile, shared parts between vehicles. The same engine type could power tanks, self-propelled guns, and even amphibious vehicles. It wasn't just clever, it was efficient. By 1944, the Allies had produced more than 125,000 tanks. Germany, less than 50,000. And while German soldiers often fought with courage and skill, courage couldn't repair a broken gearbox. Bravery couldn't replace an engine. For those Wehrmacht mechanics staring at the captured Sherman engine, this realization hit hard. They had always believed in German superiority, that their machines were the finest in the world. But now they were seeing the future of warfare, and it wasn't about craftsmanship anymore. It was about systems. Production systems, supply systems, logistic systems. All the invisible gears that kept an army moving long after first shots were fired. And in that sense, Germany had already lost long before the Allies landed in Normandy. In the quiet of their workshop, the mechanics reassembled the engine and watched it come to life. It started smoothly with a deep, steady hum. No smoke, no sputter, just raw, reliable power. They looked at each other, silent, thoughtful. There was respect in their eyes, maybe even envy, because in that sound, they could hear the truth of the war. The Americans weren't just outbuilding Germany. They were outthinking them. The captured Sherman engine had become more than a machine. It was a prophecy, a glimpse into a world where quantity had its own kind of quality, where reliability defeated perfection. And for the men who had devoted their lives to keeping the Wehrmacht steel beast alive, it was both inspiring and devastating. Because now they knew, no matter how many victories Germany claimed, no matter how many tanks they built, they could never outpace a nation that had turned its factories into an unstoppable army of machines. As 1944 bled into 1945, the German war machine was running on fumes. Factories bombed, supply lines shattered, and cities burning. Yet deep within workshops and repair depots, men still worked, welding, grinding, rebuilding, trying to hold together what little remained of the once unstoppable Wehrmacht. The mechanics who had once marveled at that captured Sherman engine now lived the nightmare it had predicted. The parts shortages they had whispered about were now catastrophic. Tanks rolled into battle with mismatched wheels, patched armor, and improvised components. Crews often carried hammers and wire instead of spare parts. But the Allies never slowed down. By now, the skies above Germany were filled with the deep, constant drone of American bombers, B-17s and B-24s by the thousands, each powered by engines born from the same mass-production philosophy that had built the Sherman. The Allies had turned industrial warfare into an art form, and Germany was suffocating beneath it. The mechanics began to see the same story everywhere. Captured Allied trucks, jeeps, and tanks all carried that same unmistakable signature: simplicity, standardization, and endurance. The engines didn't need special fuel. The filters could be swapped with replacements from entirely different models. Even ammunition calibers were streamlined. Meanwhile, in Germany, chaos reigned behind the front. Every new tank design came with a new set of parts, new tools, new instructions. The Tiger, Panther, and King Tiger, engineering marvels, yes, but each a nightmare for logistics. The complexity that once made Germany proud had become its curse. And those who understood this best weren't generals or ministers. They were the mechanics. They saw the truth in every seized crankshaft and broken piston. They watched as supply convoys arrived lighter each month, bringing fewer parts and thinner oil. They knew the war wasn't being lost in trenches. It was being lost in the factories, in the foundries, in the endless maze of Germany's over-engineered ambitions. One evening, in a bomb-damaged workshop near the Western Front, a small group of these men stood quietly around the same captured Sherman engine they'd studied months before. It had been kept as a curiosity, a teaching piece. But now it was something more. It was a reminder of what could never be achieved. They stared at it, still running smoothly after months of use, barely serviced, still defying the mud and dust of war. Around them, the air shook from distant artillery, the sound of the front creeping ever closer. One of them muttered, "This thing runs like it doesn't know there's a war going on." The others nodded. None laughed this time. For them, that steady hum wasn't just mechanical, it was symbolic. It was a sound of inevitability. The sound of an enemy that didn't tire, didn't falter, didn't stop. In that moment, the truth was undeniable. The Sherman engine, the one they'd once disassembled and mocked, represented the triumph of industrial democracy over dictatorial perfectionism. While Germany's war economy had been enslaved by politics and pride, America's had been liberated by innovation and scale. The U.S. could draw upon resources from every state, every factory, every worker. Women worked the lines, immigrants filled the shifts, and entire cities turned into machines themselves. Ford's Willow Run plant produced one B-24 bomber every hour. Shipyards launched entire Liberty ships in days. And while the Germans designed masterpieces, the Americans built momentum. That was the moment the mechanics understood wars were no longer decided by tactics or generals alone. They were decided by who could build faster, simpler, and smarter. When Germany's fuel ran out in the winter of 1945, the front lines froze. Panzers stood idle, their engines cold. Mechanics drained one vehicle to keep another alive. Trucks were converted to run on with gas. The Luftwaffe grounded entire squadrons because synthetic fuel plants had been bombed to rubble. But the Americans? They rolled forward endlessly. The Sherman engine, built in the thousands, never stopped. For every one destroyed, 10 more took its place. The sight of endless convoys, columns of Sherman's half-tracks, and trucks stretching to the horizon broke something in the German psyche. The frontline soldiers still fought bravely, but even they began to whisper what the mechanics already knew. You can't fight numbers. Inside the ruins of Germany's once mighty factories, engineers and technicians stared helplessly at idle machines. No steel, no fuel, no power. Their masterpiece tanks became immobile monuments to a lost era, brilliant, but doomed. And that Sherman engine, still running, became a haunting reminder of what the war had become. It was no longer about who could design the best machine. It was about who could replace it faster than the other side could destroy it. By April 1945, Berlin was burning. The last panzers fought to the end, magnificent machines surrounded by a storm of simpler, cheaper, relentless Shermans. The war that began with blitzkrieg ended with attrition. The nation that worshipped perfection was crushed by the power of production. In the post-war years, Allied engineers and historians pored over captured German documents, marveling at the brilliance of the Tiger and Panther designs. But the men who had actually fought the war, the mechanics, the logisticians, the soldiers in mud, they knew what really mattered. It wasn't about horsepower or armor thickness. It was about how many engines you could build before the next battle. That captured Sherman engine, preserved for study, later became a teaching tool in post-war Germany. Engineers and apprentices examined it, not with arrogance, but with admiration. It became a symbol of the lesson that had cost millions of lives. The understanding that efficiency, standardization, and scalability were the true weapons of modern war. The same principles that power that engine would go on to rebuild the world. American industry, once devoted to war, would turn its power to reconstruction, producing cars, planes, and tools that reshaped the global economy. For Germany, it was a humbling but transformative realization. The nation that had once prided itself on elite engineering learned that greatness didn't come from complexity alone, but from the power to multiply it. And so, in a strange and silent way, that captured engine, a relic of war, helped lay the foundation for a new Germany. A Germany that would one day lead the world again in engineering, not through domination, but through discipline and design. Back in that muddy workshop, as the war drew to its close, one of the mechanics, weary, covered in oil, placed his hand on the warm metal of the Sherman's running engine. The sound was steady, calm, eternal. He whispered, almost to himself, "They built it to last the war. We built ours to prove we could." The others said nothing. There was nothing left to say, because in that hum, that deep mechanical heartbeat, lay the truth of the entire conflict. A truth that echoed across the wreckage of Europe. Wars aren't won by the most beautiful machines. They're won by the ones that never stop coming.